Hello everyone, welcome back to the channel. So today I will be solving a Leetcode hard problem which is of topic tree, and the problem is from weekly contest 317. The problem's name is height of binary tree after subtree removal queries. Okay, so let's move to the problem statement. Here we are given a binary tree which have n nodes, and each node is assigned a value between 1 to n, and all the values are unique. Now what we have to do is we have a queries, and in each query we are given the value of the node, and we have to remove complete subtree at that node. Now after this removal, I have to answer the maximum depth of the maximum height of the binary tree. Okay, and now after answering this query, I will insert that subtree again back to the tree. Now I have to solve this. So let's move how to solve this. Okay, so as we can see, we have a subtree type of queries. So most of the subtree problems can be solved using Euler tour. So here also I will try to explain with Euler tour. So what Euler tour is? Okay, it's basically a normal DFS, but here I have to maintain a start and end time of each node, like at when which time we get this node, and at which time we are out from the subtree of this node. Okay, so I will start from 1 because DFS start from root, and here root is 1. So start time of 1 will be 1 because we get this at time 1. Okay, now we get into 3. Now start time will 3 will be 2. Start time of 2 will be 3, and now there are no nodes in the subtree of 2, so it will end here only. So end time of 3 will 2 will also be 3. Now it will go back to 3, and end time of 3 will also be 3 because the maximum end time nodes in the subtree of 3 is 3. Now it will go back to 1, but all the nodes of 1 are not covered, so it will go to 4. Okay, now start time of 4 is 4. Okay, now it will go to 6. Start time of 6 will be 5. It will go back to 4. Now all nodes of 4 are not covered, so it will go to 5. Start time of 5 is 6, and start time of 7 is 7. Now all nodes of 7 are covered, so end time of 7 is 7, end time of 5 is 7, end time of 4 is 7 because maximum end time of all the nodes in subtree of 4 is 7, so it is 7. Oh sorry, I missed it. End time of 6 is 5 because the end time of maximum of end times of all the nodes in subtree 6 is 5, and end time of 1 is 7. Okay, so this I will get after Euler tour. Yeah, so how can I use this? We have the start and end time of all the nodes. Start time is of red color, and end time is of blue color. Okay, so how can I use this? So when I get a query to remove the subtree with value 4, which means I have to remove subtree rooted at this point, then I will remove all the nodes which have start time in between 4 and 7. So this has 5, it will be removed. It has also 4, it will also be removed. It has 6, which is in between 4 and 7, so removed. 7 will also be removed, but these three have a start time less than 4, so these three will not be removed. So my new tree will be this. This is valid for all type of nodes. Like if I get a query to remove yeah, if I get a query to remove node with value 5, so start time of 5 is 6 and end time is 7, so all the nodes in between 6 and 7 start time will be removed, so only this is and this is present, so this will be removed, and rest is my left tree. So how can I use this? Yeah, first I need to find the depth of each node also, which is the maximum height from the root node. So I will do this in Euler or DFS, using DFS also. So height of this will be 0, it will be 1 1 2 2 2 and 3, because yeah sorry, depth will be 0 1 1 2 2 3. Okay, so how can I use this? Okay, so when I remove this subtree, let's show this with another color. When I remove this subtree, my answer will be the maximum depth of all the left nodes, which is 0 1 2. So maximum depth will be 2. My answer for this query will be, so how can I use this? Okay, so I can first maintain the depth in a vector or map using start time. Okay, so let's explain this. Index are my start time 1 2 3 4 5 6 7. Okay, node with start time of 1 has depth of 0. Okay, node with start time of 2, which means this, has a depth of 1. Node with start time of 3 has a depth of 2. Node with start time of 4 has a depth of 1. Node with start time of 5, which is this one, has a depth of 2. And node with start time of 6, which is this one, has a depth of 2. And node with start time of 7, which is this one, has a depth of 3. Okay, so now for the node with the value 4, I will remove all the nodes in between 4 and 7, because endpoint of 4 is 7 and start point is 4. I will remove this, so my answer will be before start time maximum before start time, and maximum before end time, and maximum of both. So how can I use this? I can maintain a prefix maximum array which will find the maximum answer up to this maximum depth, up to this, and suffix maximum array which will find the maximum depth up to this start time, up to this start time, up to this. So my answer will be maximum of the start time of this node, prefix of start time of this node minus 1, which is this, start time of 4 minus 1 is 3 here, and prefix of this will be give maximum of all these, and maximum of suffix of end time of this, which is 7 plus 1. So it will be from 8 to endpoint, maximum of both. So it will be easy to understand with the help of code. So let's move to the code part. Okay, here I have maintained a start, end, and depth map, and time is 0. So I will first make a Euler tour, yeah, and start time of current node with value is equal to plus plus time. So this will give me this part, sorry, this will give me the red part, start time of all nodes, yeah. Start time all node, start time of root will be plus plus time, which is initialized with 0, is 1. Now depth of start time of this node, matlab my index is start time, not the value of the node. So depth of start current node value is depth, which is initialized with 0. Now if my current dot left of current is exist, then I will make this part, this will go into recursion, and if current right exist, then this will go here, and at end I will use this end time, yeah. So from this I will get these things about, I will get these data about the tree, like start time, end time, and depth of each node. I will get this. Okay, so now depth dot size is n, which means the, like, if there are n nodes, how to find the number of nodes in the tree, because I need that later. So the size of map will be the number of nodes in the tree, sorry, the size of depth will be the number of nodes in the tree, because each node is pushed only once. So size of map will be the number of nodes. Okay, now I will initialize prefix and suffix with number of nodes plus 2, and this is the usual part that I have said, yeah. prefix of I is maximum of prefix of I minus 1 comma current depth. The node with start time of I has a depth of depth I, and the maximum of all the nodes with start time of less than I is prefix of I minus 1. So prefix of I is maximum depth of all the nodes with start time less than equal to I, and for suffix of I will be maximum depth of all the nodes with start time greater than equal to I. Yeah. Now my query will be current value is x, so start time of node with value x is start of x minus start of x, and I have to calculate the prefix before this, so start x minus 1, and end time of current node with value x is end x, so the next one will be end x plus 1 answer dot pushback max of prefix st comma suffix ed. So this will give me the correct answer. Yeah, let's submit this. Yeah, it is correct. So thanks for watching. If you have any doubt or query, you can ask me on my Discord server or LinkedIn or any of the social media handles. I've attached the links of those in the description below, and the solution link I will also attach in the description. Thanks for watching. Bye.